Hi, this is Physics Unit 1, May 2015. Let's start. Number 1. A moving object has a uniform non-zero acceleration. Uniform means there is a constant acceleration. The acceleration is constant. Which velocity time graph shows this? So basically, a velocity time graph is a graph where we have velocity in the y-axis and time in the x-axis. We also know that the acceleration of the object is uniform. So basically, what is the acceleration in the velocity time graph? In the velocity time graph, the acceleration is actually the gradient. Since acceleration is change in velocity by time, right? Change in velocity by time is actually y-axis by x-axis, since in the y-axis we have velocity and in the x-axis we have time. So y-axis by x-axis is the gradient, and the gradient of a velocity time graph is acceleration. Since the acceleration is uniform and non-zero, it means that the graph would be of a constant gradient but non-zero. Non-zero means that the graph would look something like this or this or this, something like this, which is non-zero. A graph with a zero gradient is actually this. So a non-zero uniform acceleration, this is only possible in this option A. So the correct answer is option A. Number 2. Physical quantities are either vectors or scalar. Select the row of the table which correctly identifies vector and scalar quantities. So what is a scalar quantity? Scalar quantity is a quantity which has only magnitude but no direction, right? It only has a magnitude but no direction. This means that a magnitude simply means that there is only a value but no direction. For example, time, we can say 5 seconds or 10 seconds or 15 minutes or 1 hour or 50 hours, anything like that, but we cannot say the time is 50 seconds due east or due north. We cannot have a direction there. Same goes with mass cannot have a direction. For example, we can say 5 kg or 10 kg, but not 5 kg downwards or upwards. Mass does not have a direction but has a magnitude. That magnitude is the value that we are talking about: 5, 10, 15, 25, 100. All of these are values, but directions are just that. So what is velocity? So basically velocity is the displacement by time, right? So there are two things. One is speed. Speed is the, and the velocity is displacement by time, right? So distance. So basically for distance, let me just clear out. So for example, we move from this point to this point and this point to this point. So this point is A, B and C. The distance between A, B is 20 kilometers and the distance between B and C and 20 kilometers. So speed is basically distance by time. Distance is the total path covered when traveling. So basically the distance here is 20 plus 20, which is 40 kilometers, but the displacement is actually the shortest distance between 2 points. So this from A to C, this distance is the shortest distance, which is root over 20 squared plus 20 squared, right? 20 squared plus 20 squared, and there is an angle. So we can say that the displacement is root over 20 squared plus 20 squared due east or due west or due north, something like that. So displacement has a direction, but distance does not have a direction. It has only the magnitude. So distance is 40 kilometers and the displacement is the one I just said. So distance is scalar, speed is scalar. Since displacement is vector, velocity is vector. So have mass. So mass is a scalar quantity since it only has a magnitude. Velocity has both magnitude and direction, so it is a vector quantity. Mass is a scalar quantity and displacement is also a vector quantity. So the only answer is D, since this matches with all of the options. So the correct answer is D for number 2. Number 3, the following arrangements all contain identical springs shown unextended. So these all are identical springs. So basically there is one spring and here there are two springs. So basically the spring constant is doubling here, this height. for the same spring there are two springs, right? So if there is F equals to kx for two springs, for one spring there is F equals to kx, or for two spring there would be 2kx. So basically for every constant force there would be a lower extension if there are two springs attached, right? Since first, for example, if we hang 20 kg here and 20 kg here, then this extension would be the double for this extension. This is because 20 kg is now being handled by two springs. So 20 kg is basically each spring would be taking 10 kgs, but one spring is taking the full load, right? So clearly this extension would be greater than this extension. So we have 30 kg, then this spring will have 30 kg. For this spring will take 30 kg and this spring will also take 30 kg. For part B, these two springs each will take 15 kg and this will take 30 kg, and for this spring 15 and 15. So we can clearly see that these two will extend the greatest. So the correct option is C, since in option C the load is not being divided between the springs. Number 4. A ball is dropped and bounces 3 times before being caught. So a ball is here we have a surface and the ball is dropped from here. It bounces, it reaches the ground, goes back up, reaches the ground, goes back up, reaches the ground, and then it is caught. So we can see that the highest height reached decreases, right? It decreases, and we also know that the total energy is equals to GPE, gravitational potential energy, plus KE, which is kinetic energy. So when the ball is dropped from this height, there is maximum gravitational potential energy and zero kinetic energy. Since kinetic energy is equals to half mv squared, since there is zero velocity, there is zero kinetic energy. So slowly the gravitational potential energy starts decreasing as the distance between the ball and the ground decreases. So the gravitational potential energy decreases and the kinetic energy starts to rise. So basically the total energy remains constant when it is going down. The total energy remains constant. Simply, total energy being constant, the gravitational potential energy is being converted to kinetic energy. So from this equation we can say that the left hand side is always equal to the right hand side. The total energy is always equals to GPE plus K, since these two energies are interchangeable. So basically when the ball is going down, the gravitational potential energy decreases and K increases, and at this point when the ball has reached the ground, the gravitational potential energy falls, the gravitational potential energy is minimum and the kinetic energy is maximum. At this point we can clearly see that when it again rises up again, the kinetic energy then becomes converted to gravitational potential energy as it is going upwards. But the thing to notice here is that when the ball again goes up, the highest height reached is actually lower than the previous one. So basically the thing is, when it is at the highest height, the kinetic energy is always zero, right? The kinetic energy is always zero. So basically the gravitational potential energy is equals to mgh, right? This height is lower, so which means that the gravitational potential energy at this point is lower than this point, right? So this basically means that the total energy is decreasing. So where does the total energy go? Basically the total energy goes out of the system. This is because when it bounces with the ground, upon impact some energy is lost as heat and sound. When we bounce a basketball on the ground, we always hear right? Basically at that point the kinetic energy of the ball is being converted to sound energy, sound waves, since a wave is a form of energy transfer, right? So the sound we hear is basically being converted from the kinetic energy. So upon impact the total energy is actually decreasing. So basically the total energy is decreasing. So B is not correct since the total energy is constant, right? So upon impact, the total energy is decreasing. So here it's in the impact, here it is being in impact, and here it is being in impact. So in impact, the total energy is decreasing, and since I have told that the kinetic energy is zero at the maximum point, right? So basically the kinetic energy at the maximum point is equal to the energy, right? Since at that point, since total energy is equals to the kinetic energy plus gravitational potential energy. So at the highest point, when the kinetic energy is zero, the velocity is zero, the total energy is equal to the kinetic energy. So this proves that this point has a common line, right? This total energy is being intersected by this curve type, right? So this proves that at the height, the gravitational potential energy is equal to the total K. So the answer is C. Number 5. A force being applied to a length of wire. Which of the following statement is not correct for a small deformation of the wire? So basically, if we plot the graph for force and extension, so we have force here and extension here. We know that F equals to K into X, right? This is the Hooke's law. So this proves that the force is proportional to the extension, right? Provided that there is a spring constant. So basically, if the force is proportional to the extension, and this is the extension and this is the force when plotted on the graph should look like a straight line passing through the origin, right? A straight line passing through the origin where the gradient is equal to K. The gradient, the change in y by change in x, or force or x of by extension, is equal to the K constant. So which of the following statement is not correct for small deformation of the wire? So as the wire is applied increases, the extension increases. So this is right, correct, because when the force increases, the acceleration increases and our points go along the curve in this direction. Part B says that the force is applied is directly proportional to the extension. This is also correct because here we have a constant K and the gradient is constant, so it's directly proportional. The force applied is directly proportional to its original length. This is not a correct answer since it is directly proportional to its extension. It does not matter what the original length is. The extension is dependent on the value, the constant value K here and here, the constant value K, not the original length. So this is the wrong answer. This is not the correct answer. So it's the correct answer for this question. And the stress is directly proportional to strain. This is also correct since Young's modulus is equals to the stress by strain, right? Stress by strain. So basically the Young's modulus of every material is constant. Since this is constant, the stress increases, the strain also has to increase to keep the Young's modulus constant. So D is also a correct answer. So the only answer applicable for question 5 is C. Question 6. Aluminium can be used to produce thin sheets of food wrapping because it is. So basically thin sheets of food wrapping is basically we take a large aluminium like this, we take a large block of aluminium and we exert a force from this direction and this direction until it is thin as a paper, right? It is thin as a paper. So basically this is compressed and it becomes this shape and then it becomes just a straight aluminium sheet, right? So basically we have a compressive force here. So part A says that it's brittle. So if the aluminium was brittle, we could not exert a force to deform its shape, right? It would break. Brittle is basically the property of breaking easily. So A is not correct. B is not correct because B is technically a close answer, close to be corrected answer, because ductile is basically getting deformed but in a tensile way. For example, if we pull a rubber band with our two hands in the opposite direction, when we are extending the rubber band, this is known as a tensile force, right? It is being extended, the shape of the rubber band is being changed, but it is not a compressive force. So B is not correct. C is not correct. If it was hard, it is basically the property that prevents a material from being scratched. For example, we now have Gorilla Glasses in our iPhones, right? In our iPhones and in other devices we have Glass. So this Gorilla Glass basically prevents scratches, from dust particles or keys in our pocket, anything. This is the property for hard. So malleable is very similar to ductile, but the thing is both ductile and malleable undergo the change in shape, but the methods are different. In malleable we have a compressive force like this, and in ductile we have a tensile force, a force of pulling, change the shape of an object. In both ductile and malleable, change the shape, right? We change the shape, but only in malleable at a compressive force. So the correct option is D. Number 7. A motor takes 10 minutes to lift a mass of 40,000 kg through a height of 5 meter. The minimum power of the motor in watts can be found using. So basically the power is basically work done or energy by time, right? It is the energy by time. And what is the energy? A motor takes 10 minutes to lift. It is being lifted. So the motor is basically working against gravity per second, right? So the energy is basically a form of gravitational potential energy by time. So we need to calculate the gravitational potential energy, which is mgh by time. So m is basically the mass. The mass is 40,000, and mass into gravity is 9.81, and the height is basically 5. And the time, what is the time is basically we need to convert the time into seconds, right? So time into seconds is basically 10 into 60, since 1 minute is equals to 60 seconds. So 10 minutes is equals to 10 into 60. So 10 into 60. So the correct answer is B, since this correctly matches with the one I have written. So for number 7, it is B. Number 8. A small stone dropped into a well takes 1.5 seconds to reach the water. So basically we have a well over here, and the well goes down. This is the surface of the well, and the well goes down like this to the bottom, and when a person throws an object, it goes down, and when it reaches the ground, after 1.5 seconds, right? So ignoring the effect of air resistance, what distance did the stone fall through? So basically we have to use the Suvat equations here. So SUVAT, where S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is the time, right? So we need to find the displacement. We have the initial velocity of 0, since it is says that the stone is dropped. The final velocity, we do not need that. The acceleration is g, right? The acceleration is g, gravity. For earth, the value of g is 9.81, and the time is 1.5 seconds. So basically we have s equals to ut plus half at squared. So the value of u is 0 and the time is 1.5. So 0 into 1.5 is basically 0, into half into a is 9.81, which is the acceleration due to gravity, and time is 1.5 squared. So basically we have the answer which rounds to 11 meter. So the answer to number 8 is B. Number 9. A swimmer jumps from a diving platform into a swimming pool. The swimmer is slow to stop by friction with the water. So basically it is slow to stop by friction. The total work done by the water on the swimmer does not depend on. So basically the thing is, for example, this is a pool, right? This is a pool, and we have a sort of a stand here like this, and the swimmer, basically the swimmer, if the swimmer is here, the swimmer jumps into the pool. So which of that, so jumps into the pool and the swimmer just goes into the pool, right? Since if this is a pool, the swimmer just goes into the water, and the water does work on the swimmer. So work done is basically force into distance, right? So Basically, for example, the swimmer goes from the surface to a little deep, for example 10 meters. So basically the work done is basically the force being applied by the water into 10, the distance, right? So the frictional force is basically 6 pi nrv. This and pi are constants, and n is the viscosity of the water, r is the radius. So basically radius is basically the volume, and v is the velocity of the swimmer, or the mass of the swimmer. So mass of the swimmer will apart, since if there is a higher mass, so a higher mass would have a higher velocity. So a higher velocity this higher velocity would prove that there is a higher force, right? So a is correct. A would depend on the mass of the swimmer. B says that the speed of the swimmer on entering the water. This is also correct, since if the velocity increases, the force would increase. The depth of the pool would affect the work done. Part D says that the height, yes. So the higher height, since if it goes to a higher height, speed with which swimmer will reach the pool is higher, and if the speed is higher, the work done by the water is higher. So the correct answer to this question is C. Number 10. A glue dispenser produces small droplets of glue. The glue dispenser contains a small heater. So since there is heater, the temperature will be rising. The graph shows how the speed of a droplet leaving the dispenser varies with temperature of the glue. So as the temperature increases, the speed increases, right? The speed increases. So a higher temperature of glue is preferred because, so when the temperature is higher, we know the graph of viscosity against temperature, right? In the y-axis we have viscosity, and the x-axis we have temperature, right? So the graph is basically like this. So viscosity is basically the resistance to flow. So if the resistance to flow increases, the rate of flow will actually decrease. So at a higher temperature there is lower viscosity, right? The lower viscosity, there would be a lower viscosity. Since viscosity is the resistance to flow for a liquid, with the lower viscosity there would be a higher speed. So the correct answer to number 10 is C. Guys, that was the end of the paper. If this paper was helpful, if the explanations were helpful, please consider liking and subscribing. Good luck for your exams. You've got this.